Hi, this is section 8.2 on arithmetic sequences. So an arithmetic sequence is a sequence that has a common difference, which is D. So a common difference is when you add the same number to the each time to get the next term. So this is what I mean. So if you look at this sequence down below, to get from the first term to the second term, it looks like you're adding 4. So let's see if that is in the case for each term. If you add 4, you get -2. If you add again, you get +2, and so on and so on. So that is the common difference. And the way you can get the common difference is by subtracting a term minus the previous term. All right. So that's the way you can get the common difference. So you can do -2 minus -6, for example. And the double negatives become plus, and that gives you 4. And that's exactly what we got here, 4. So the common difference is 4. All right, and so that's basically how you show that this is an arithmetic sequence. All right, so let's keep going. So there are 2 formulas for determining the nth term of a sequence. So the nth term of the sequence is given by this formula, or you can use this formula. We'll probably use both, but for now we're going to start with the top one. So let's look at this. It says find the nth term. So what we need to do is use the top formula, because that is the formula for the nth term. Then they want us to find the 5th term and also the 10th term. And they tell us that it's arithmetic. We can confirm it. Let's find the common difference. D is going to be the 2nd term minus the 1st term, which is -3. So if you subtract 3, you get 13. If you subtract 3, you get 10. If you subtract 3, you get 7, so on and so on. All right, let's find the nth term. So a sub n is equal to a sub 1 plus n minus 1 times d. All right, we know a sub 1, that's the first term in the sequence, that's 16. And we don't, that's our variable in this case. And d, we already figured that out, it's -3. So now we distribute and combine like terms. So that's 16 minus 3n plus 3. And if you combine like terms, you'll get -3n plus 19. So that is the nth term of the sequence. It's -3n plus 19. All right, let's use it to find the 5th term. So to find the 5th term, we're going to plug in 5 for n. So that's going to be -15 plus 9, which is 4. Which makes sense because if you subtract 3 again, you're going to get 4. All right, so let's find the 10th term now. So substitute 10 for n. And you get -30 plus 19, which is 11. All right, -11. So that is the 5th term and the 10th term. All right, let's keep it moving. Same thing. This time there's decimals, but don't let that scare you. It works exactly the same way. Let's start off by finding D. 2nd term minus the 1st term is how you get D. So double negatives is plus, so that's going to be 1.5. Is our common difference. So if you add 1.5, you get that. If you add 1.5 again, you'll get that. If you add 1.5 again, you'll get that. So on and so on. Let's find the nth term. All right, the first term is given to us. It's -6. N is our variable, and D is 1.5. Distribute and combine like terms. Should get 1.5n minus 6 minus 1.5. That's going to be -7.5 if you combine like terms. That's -1.5 and -6. If you combine those, you get -7.5. So that is our nth term. Now we can substitute any number we want for n, but they specifically ask for a sub 5 and a sub 10. So let's start with 5. 1.5 times 5 minus 7.5 is going to be 0. And a sub 10 is going to be 1.5 times 10 minus 7.5. That's going to be, should be 7.5, which it is. And those are the two answers. You can pretty much check that it's true, because if you add 1.5 to this term, you're going to get 0, which is the fifth term. Okay, find the specified term of the arithmetic sequence that has the two given terms. Okay, so they're giving us back-to-back terms. Whenever they do that, back-to-back terms means you can find the common difference. And the only reason we can do this is because they're telling us that it's arithmetic. So let's do second term minus first term to find the difference. And it is negative 1.6 is our common difference. Now let's find the nth term, a sub 1 plus n minus 1 times d. First term is given to us, 9.1. And d is, we found that earlier. So now we're going to distribute, combine like terms. Should be negative 1.6n. This is going to become a positive 1.6. 1.6 plus 9.1 should be 10.7. So now we know the n term. Now we can substitute any values we want for n. And they specifically are asking for the 12th term. So let's find the 12th term. Plug in 12 for n. And let's see what that is. I'm getting negative 8.5. That should do it. That is our final answer. Okay, let's keep moving here. All right, same thing. This time, notice they do not give us back-to-back terms. So when they do not give you back-to-back terms, you can't find the common difference like we did over here. So we're going to use the second formula for that. So let's do that. So notice here it is. I'm going to copy it over. So it's a sub n equals a sub k plus n minus k times d. Okay, so let's plug in our values. All right, so ignore this for now. You're only focusing on these two. All right, so let's see what we got. Let's go with, this is our n, our a sub n. This is our n. This is our a sub k. This is our k. So we got 2, 3, 6, 4 equals 2, 0, 1 plus n, which is 317, minus k, which is 8, times the common difference, which is unknown. So now we have to work this out and solve for d. So I'm going to start off by subtracting 201. So that's going to be 2163. And this is going to be 309b. Divide both sides by 309 and you get 7. So now we got the common difference. Okay, once you have the common difference, now we can, let's see, what can we do now? All right, so now let's go back to the first one, a sub n equals a sub 1. Actually, we should be able to use the same formula. So let's use the same formula. All right, now that we have d, okay, so let's use this. All right, so we got a sub n, which is a sub 410 is what we're looking for. A sub k, we can use this, which is 201, plus n, which is 410 is your n, so be careful there. 410 is your n. K is 8, and D is 7. So this is what we're going to evaluate. Use your calculator if you need to. I'm going to use mine. And I'm getting 30, 15 as my final answer. All right, so notice that I used, once I found D, so this was my A sub n, A sub k, k. Over here, I used my n that I wanted, that they're asking for, and then I used my A sub k and my k, and this was my n. Okay, moving on. So now we're looking at partial sums. So the partial sum is given by this formula, and there's two versions. What you can do is you can use the formula for A sub n, which is A sub 1 plus n minus 1 times d. So they substituted that here, and then they combined like terms, and they ended up with this. So these two formulas are equivalent. You can use either one. All right, so let's see. They want us to find the sum of the first 30 terms. So they give us the first term, and they give us the common difference. Because they give you the common difference, I would go with this one. So let's go with this one. So it's going to be A sub 30, which is n is 30 over 2 times the first term, plus n, which is 30, minus 1 times the difference, which is negative 3. And you can use your calculators at this point, or you can do it by hand. It would be, what is this going to be? This is going to be negative 87. Okay, so should get, your final answer should be negative 105. That would be the sum of the first 30 terms. All right, let's look at this one now. So this time, they don't give us the first term. So because they don't give us the first term, it's not as simple as the previous problem because we don't know the first term. So what we do is we have to find the first term first, and you can do that by using this formula, the nth term of an arithmetic sequence. So we know the nth term is 7/3. We don't know the first term, and we know n is 7. So you're ignoring this n for now. You're using this as your n in order to find out what d is. I'm sorry, we already know what d is. In order to find out what a sub 1 is. All right, so now we have to solve for a sub 1. So this is going to be 6. 3 goes into 6 twice, so that's going to be negative 4. Add 4 to both sides. And 4 is the same thing as 12 over 3. So 12 plus 7 is 19 over 3 is our first term. Okay, now that we have our first term, now we can use this formula that we used previously. So let's do that over here. S sub 15, and now we use 15 as our n, is equal to n over 2, 15 over 2, bracket 2 times a sub 1. A sub 1 is 19 over 3, plus n minus 1 times d, plus n minus 1 is 14, times d is negative 2/3. All right, so I would definitely recommend our calculator here. So let's see what this is. All right, so I'm getting 15 over 2 times 10 over 3. All right, and that is going to be 3 goes into 15 5 times, 2 goes into 10 5 times, that's 25 is our final answer. The sum of the first 15 terms is 25. Okay, the next problem says find the sum of this series So in order to find the sum, we're going to substitute 1 in for k. So that's going to be 1/2 plus 7. Then we substitute 2. That's going to be 2/2 plus 7. Then we substitute 3. 3/2 plus 7. Keep doing that. Dot, 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 until we get to, I'm going to go with 17. And then finally 18 is where we stop. Okay, so this is our 18th term, 17th term, first, second, third, fourth, etc. All right, so what do we notice? There are, how many 7s do we see? Well, there's 18 7s, so we know that there's 18 7s plus, and now we have to add 1/2 plus 2/2 plus 3/2 plus 4/2 plus 17/2 plus 18/2. So let's factor out the 1/2, and then that will just be 1 plus 2 plus 3 plus dot, 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 plus 18. So I'm taking all of these and I'm adding them up. However, I'm factoring out the 1/2 so that I just have 1 through 18 added. And the nice thing about that is we can figure that out just by using the formula n over 2 a sub 1 plus a sub n. So that's the formula, the sum of 18 terms, 18 over 2. The first term is 1, and the last term, the 18th term, is 18. So we have 18 divided by 2, which is 9, times 19. Which is 171. All right, so now we have 18 times 7, which is 126 plus 1/2 times 171 is what we got up here. That's the sum of the first 18 terms. And so now we should be able to do this. Let's see. Might have to get a common denominator here, 1, and then multiply top and bottom by 2. So that's 126 times 2 plus 171, which is 423 over 2. So that is our final answer. All right, express the sum in terms of summation notation. So let's see if this is an arithmetic sequence. Plus 5, plus 5, plus 5, plus 5. It does seem like it is an arithmetic sequence because it keeps on increasing by 5 each time. And since we know the first term, we should be able to find the nth term now. All right, so let's see. Oh, actually, that's a minus. All right, so let's see. The first term is going to be 3 plus n minus 1 times 5. Distribute, combine like terms. You're going to get 5n minus 2 after you combine like terms. So you write a summation symbol. And we're starting at k equal to 1. And because there's 1, 2, 3, 4, 5 terms, the top number is 5. That's just the number of terms if you're starting at 1. And then the formula is given by the nth term. So the formula is 5n minus 2. And you can test it out. Plug in 1, you get 3. Plug in 2, you get 8. Plug in 3, you get 13, so on and so on. Okay, let's look at this one. So for this type of a problem, most likely we're going to separate the numerators from the denominators, or you're just going to think do these separately. So let's look at the numerator to begin with. It looks like it's plus 3, plus 3, plus 3, plus 3, plus 3, which it is. So for the numerators, the common difference is 3. So a sub n is going to be a sub 1 plus n minus 1 times d, which is 3 plus n minus 1 times 3. So the nth term is given by 3n, 3n. The negative 3 and the positive 3 cancel. Now let's look at the denominators. So plus 4, plus 4, plus 4, plus 4, plus 4. So the difference is plus 4. Same thing. First term is 7, and minus 1 times 4. Distribute and simplify, you get plus 3. So the formula is going to look like this. We start at 1, and how many terms are there? 1, 2, 3, 4, 5, 6. So we're going up to 6. So for the numerator, the formula is 3n, and the denominator is 4n plus 3. And same thing, you can test it. If you substitute 1, you're going to get 3 over 7. If you substitute 2, you're going to get 6 over 11, so on and so on. Okay, the next problem, it says, find the number of terms in the arithmetic sequence with the given conditions. So when they ask you to find the number of terms, that means you're looking for n. All right, so let's write this out. The formula, if you recall, is given by, I'll just copy and paste it, make it easier on us. All right, so we know the sum. The sum is given to us, it's 21. We don't know n, that's what we're looking for. We know the first term is -2. We don't know n, that's what we're looking for, and we know the difference is 1/4. So since we only have one variable, we should be able to solve. So let's see if we can do this. So let's distribute, combine like terms. Okay, this is what we're getting so far. All right, let's get a common denominator times 4 times 4. That's -16 minus 1 is -17. So we have 21 equals n over 2, 1/4 n, -17 over 4. All right, let's distribute. So now we're going to have 21 equals n squared 1/8 n squared minus, let's see, that's 17/8 n. And then we can bring the 21 over. So if you subtract 21 onto the right side, you're going to get 1/8 n squared minus 17/8 n minus 21 equals 0. And let's clear out the fraction by multiplying everything by 8, LCD. And if you do that, you should get n squared minus 17n minus 168 equals 0. Now we need to see if we can factor this. Factoring might prove a little challenging, so what I would recommend is the quadratic formula. So I'm going to do the quadratic formula over here off to the side. So x is equal to -b plus minus b squared, which is -17 squared, which is 289, minus 4ac all over 2a. So 289 turns out to be plus 4 times 168. Double negatives is telling us to add instead of subtract. If you do that, you get 961. And if you take the square root of 961, you get 31. So the two answers are 17 plus 31 divided by 2, which is 24, and 17 minus 31 divided by 2 is -7. All right, so we got the two solutions, 24 and -7. However, it's not possible to have a negative number of terms, so this is an invalid answer. The answer was 24 terms. All right, a pile of logs has 24 logs on the bottom layer, 23 in the second, 22 in the third, so on and so on. So we have a sequence, which turns out to be arithmetic. And the top layer contains 10 logs. So it looks like our common difference is -1 because to get from this term to the next one, you subtract 1 each time. So the question is, find the number of total logs. So this is pile 1, 2, 3, ... We don't know what pile that is, so we have to figure out what n is. So in order to figure out what n is, we can use the nth term of the sequence, arithmetic sequence. We know the last term n, we know the first 24, we don't know n, that's what we're looking for, and we know d is -1. So distribute and solve for n, you should get n is equal to 15. So now we know that there's 15 terms, 1, 2, 3, 15. So now we need to find the total sum. So the sum of the first 15 terms, and that formula is the first plus the last, n over 2. So the first is 24, the last is 10, and we know n is 15. So now we should be able to solve for this. 15 over 2, the first term plus the last term, 15 over 2 times 34. 2 goes into 34 17 times. 15 times 17 is 255. So that is the sum of the 15 terms. That's the total number of logs. And that is the end of the section.